If you remember during quadratics, we were able to solve quadratics by multiple methods. The first one we looked at was solving by factoring. But not everything was able to be solved by factoring. It's the same thing when I look at things with higher powers, like cubed or to the fourth power. The first thing I do is check if it could be solved by factoring, because it's much faster. So let's look at my different types of factoring we did earlier in the semester. So the first thing we did were two terms. And with two terms, you could have two different patterns. You could have a difference of squares or a sum and difference of cubes. So if I want to solve the following equation, we're going to set it equal to 0 and see if it factors. So 64x to the fourth minus 49 equals 0. And I noticed that both my numbers are perfect squares and my exponent is even. So if you've got two terms, perfect squares, subtraction in the middle, let's go from there. Put your parentheses, one with the plus, then a subtraction, yes you must. Square root of the first, and we get 8x squared. 8x squared. Square root of the last. Keep them in order, and you're done fast. All right. And then, just like before, we're going to split these up and set each factor equal to 0. We're going to solve this. But when we were in quadratics, at this step, I would have had x to the first power. I would have had a linear function. The difference now is I have something squared. So that means I have two little baby equations I can solve using the square root method. Really quick and simple. Divide by 8. So I get x squared equals negative 7 over 8. And then we're going to do square root of both sides. Don't forget to put your plus or minus. So we get x equals plus or minus. And then I have square root of 7 over 8 I. Now, I know I'm going to drive you crazy because probably your geometry teacher or earlier math teacher said not to leave square roots in the denominator. Guess what? We don't really care. So we're going to leave that square root of 8 in the denominator. Just don't tell your previous math teachers. And what I'm going to do on the right side is exactly the same process. Square root of both sides, don't forget your plus and minus. So x equals plus or minus the square root of 7 over 8. Now if we did have perfect squares or something, I would keep simplifying that. Notice the only difference that I had here was that one of these had an I and one of them did not. And how many solutions do I have? I have a positive and a negative, a positive and a negative. That's a total of 4 solutions. And I started with something to the fourth power, which means I am good to go. So let's look at the next one. First step, set it equal to 0. And I notice that all my numbers are perfect cubes and my exponent is divisible by 3. So that means I am going to do SOMOS. So what cubed is 8x cubed? That would be 2x. What cubed is 27? 3. So that's 2x minus 3. And this is where we do SOMOS. So if you haven't learned SOMOS, now is the time. Square your first term, 4x squared. Opposite sign, plus. Multiply your terms, 6x. Always add, square your last term. Now what we're going to do is split these up. So 2x minus 3 equals 0. So when I solve that, I get x equals 3 over 2. Now this right side, 4x squared plus 6x plus 9 equals 0. That I can't solve by factoring. I can't use square root method because it has this 6x. So what do I need to do? I need to be doing quadratic formula. So x equals opposite b plus or minus square root b squared minus 4ac all over 2a. All comes back in this unit. Just giving myself a little bit more space. I just simplify what's under your square root. And then I'm going to simplify my square root. So I know that that is 9 and 12, 3 and 3, 6 and 2, 3 and 2. I do need to see, for full credit, I need to see your factor tree. This is all about showing our work. So I have to see all of this work. And this is why I emphasize that factoring and quadratic formula, we're going to come back in a really big way. So I can take out a pair of 3's, a pair of 2's. That gives me 6. Square root, who's left? I'm left with 1 3 right there. I over 8. My last step is to look at outside my square root. All of those are divisible by 2. So negative 3 plus or minus 3 square root 3i over 4. Remember, we don't touch what's underneath our square root. Ever, 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 ever. So we started with something way back at the top that was cubed. So how many solutions did I get? I had my x equals 3 halves, and I have this plus and minus. That gives me 2 solutions, so a total of 3 solutions. If I look at this next one, I still have a difference of cubes, but now it is to the 6th power. So I would have what cubed is 125x to the 6th. That would be 5x squared minus 1 cubed. We're setting this equal to 0. So 5x squared minus 1. And then we're going to do SOMOS. Square your first term, that would be 25x to the 4th, opposite sign, plus multiply 5x squared, always add 1. Now, notice here, I have something to the 4th power. Now, is there a really scary quartic formula? Yes. Is there anything higher than a quartic formula? No. Or maybe it's quintic. Anywho, point being, we haven't learned that. So am I going to give you something this super duper crazy? No. But I want to show you that the same property is still going to hold, that we would factor this as a difference of cubes. So focus on these first two. But I just want to review sum and difference of cubes. So we had 2 terms. We also had 3 terms. And honors, you've already seen how to factor something like this. But standard, you haven't seen this. Guess what? We're going to factor it exactly the same. And we talked about a shortcut when I have a leading coefficient of 1. But I'm going to do this problem all the way through, showing all my work with Xbox so that you understand where some of this is coming from. And then you can shortcut it. So we have our ABC, 1, negative 7, 10. First term, first box. Notice this time it's x to the 4th. Last term, last box. Multiply that diagonal, so 10. B goes at the bottom. What 2 numbers multiply to 10 and add to negative 7? You know it's one of my favorite problems here. Negative 5, negative 2. Now, usually we would put an x on the diagonal, but that would be because my middle term was x. Now I have an x squared. So I need to put an x squared. And let's factor this out like normal. Now I end up with, when I factor out, an x squared. So what goes on top? Another x squared. And then I need a minus 5 and a minus 2. So notice it's very similar to what we did earlier in the year, but I have squared. So this would factor x squared minus 5 times x squared minus 2 equals 0. And then same thing that we did above, we're going to set each of those equal to 0 and solve. I need all of this work, all of the work I'm showing I need. So I get x, we're going to do square root of both sides. Don't forget your plus and minus. So I get x equals plus or minus square root of 5. X squared equals 2. Square root both sides. Don't forget your plus and minus. Be careful on these ones if you're going to have i's. This one doesn't, but a lot of times I'll write a problem that does. How many solutions do I have? I have one plus and minus, another plus and minus. That means I have a total of 4 solutions. Trust me, when we do a test on this, you're 100% going to have one that looks just like this, so make sure you know how to solve these type of problems. The last thing we did was look at 4 terms. Now, I can't emphasize to you enough, just like in quadratics, where not everything factored. Here, not everything factors. So just because it's 4 terms does not mean the box is going to work. But if the box works, once again, it's a lot faster to solve by factoring. So I still need to see you drawing your box if you're testing to see if this can be solved by factoring. I have to see this work for you to get full credit. So we're going to factor that out. That's x squared, x minus 4, 3. We're setting these equal to 0. X minus 4 times x squared plus 3 equals 0. Split it up. X minus 4 equals 0. X squared plus 3 equals 0. So x equals 4. X squared equals 3. Square root of both sides. Don't forget your plus and minus. X equals plus or minus the square root of 3. I have one solution plus another 2 solutions, which gives me cubed. So what would this look like if it didn't work? If all I did was change that to a negative 11, when I would get down to this last step where, remember, we're going to check, here, 3 times negative 4, does that give me negative 11? No, which means I would have to use a different method, which we'll look at after we practice this a little bit.